So now we're going to start getting outside of those basic Mendelian problems. We're going to do a incomplete and codominant section. For the most part, these problems are going to have to tell you what kind of inheritance pattern you're looking at, unless that's the point of the question. So sometimes the point of the question is this showing, Mendelian genetics? Is this showing sex length? So unless it's doing that, it's usually going to tell you what it is. So if you see in this first part of this question, it says, in radishes, the gene that controls color exhibits incomplete dominance. So that's kind of easy. There's going to be some other clues in the problem, which you're going to see. It says pure breeding red radishes, I'm going to highlight that, is crossed with pure breeding white, making purple radishes. What are the genotypic and phenotypic ratios when you cross a purple with a white? So, purple doesn't come really from the red and the white, but we're just going to go with it. You're going to see, and the other clue here is that you're combining and you're blending to make a new color. Because remember, if it's codominance, both red and white would show independently. But since you're blending and getting a new color, that means it's true incomplete dominance. One thing that you're supposed to do, right, the most correct way to do these problems is to use the right letters. When you're doing incomplete dominance, you're going to do a capital for each color, and you're going to combine them to make the heterozygotes. Now, if you're doing this as a multiple choice and you're just picking the answer, the letters you use don't matter at all because no one's going to look at the letters. But it's good to kind of have good practice. So again, like we did before, I'm going to start with the parents. That's always kind of the big one. So if you look here, it says you're going to cross a purple radish with a white radish. So the only way for me to get purple, which is the blend, is if you had one capital R and one capital W. It kind of doesn't matter if you did it the other order, the W or the R. Just make sure you have a blend of the two letters. You should not be using capital and lowercase here. And that is going to be bred with a white, which the only way to do that is to have a homozygous white. Now this one's asking for a genotype and phenotype. Again, the only way to do that is to get a Punnett square. You also may see sometimes they're going to say like justify your results or something like that. What they want is just to see the Punnett square. So I'm going to do RW at the top and WW down the side. And just like we did before, you're going to fill in top side. Okay. Just make sure if you did RW first on the top, you kind of keep that convention. Like don't do RW and WR. So that's how my Punnett square is going to fill out. And then I usually just label the genotype and phenotype just so they know, that I understand which one's which. So don't forget, pheno means physical. It's what it looks like. And geno, like gene, that's the allele letters. So if we look, the phenotype here, I have 2 that are RW, which is going to give me 2 purple, and 2 that are WW, which is going to give me white. So my ratio is actually 2 to 2, which you should simplify to 1 to 1. And actually, my genotype is going to be the same ratio because we have the same letter conventions.